Welcome to Mechanical Engineering Design. In this video, we are going to look at CAD circle in CNC milling and CNC lathe. Now, in this age and era, we have found ourselves using CAM software to help us generate the CNC code. But sometimes, these softwares fail us. It is therefore necessary for you as a programmer to understand how a G-code really works. Now what you are seeing on the screen is a sample of a G-code that I have developed from this part. There are 3 holes of 12 millimeters diameter, and the origin, as you can see from top view, is bottom left. This is the origin. Towards the right is positive x-axis, the red arrow, and the green arrow is positive y-axis. Now, what are CAN circles in CNC machining? CAN circles are used to reduce program complexity. They simplify repetitive machining operations like drilling operation, tapping, boring, and threading by reducing the code length. This improves efficiency by reducing the programming time and minimizes errors. Instead of writing a long G-code sequence, a single command automates complex tasks, ensuring consistency and faster machining. This helps especially when doing manual programming rather than using a software to generate the codes. For example, in peck drilling, a 20 mm deep hole with 1 mm pecking depth would use approximately 30 lines of regular code. But with CAN circle, the same hole can be completed in just 2 lines of code. It's therefore important for you to understand how G-code works and how to go about programming in G-code. You have to master each and every G-code and also master each and every CAN circle to simplify your task. In this video, I will demonstrate how CAN circle works, their benefits, and how to use them in G-code to streamline your programming. Now, the basic format of a CAN circle is as follows: GCC, G98 or 99, X, Y, Z, Q, R, P, F, and then semicolon to show the next line of code. Don't worry, I'm going to show you what each and every letter means, especially the orange ones. Now, the first CC, as shown here, GCC, is the desired CAN circle, e.g. G81 for drilling, G83 for peck drilling, that's applied when you are drilling deep holes, 84 to mean tapping circle. Now, G99 and G98. G99, you are telling the machine to return to point R, where point R is the retract height. For G98, the tool will return to the initial point where you started machining. Then we come to X. Now X is used in 2 forms. In G90, X is the position of the center of the hole with respect to the current work 0 point. And in G91, it's the distance and direction along x-axis to the center point of the first hole from the current position. I'll demonstrate to you. Now, there is Y. In G90, Y is the position of the center of the hole with respect to the current work 0 point. And in G91, it's the distance and direction along x-axis to the center point of the first hole from the current position. What about Z? In G90, Z is the position of the bottom of the hole with respect to the current 0 point. While in G91, it's the distance and direction along Z-axis from point R to the bottom of the hole. Now, what about Q, as seen here? Q is the peck increment if deep hole drilling. That one applies in G83, and I'll show you a sample of code. R now is the retract plane above the workpiece. In G99 mode, this is the rapid plane. Rapid plane means After finishing the hole, you have to retract to a plane, maybe 5 millimeters above the workpiece, and then go directly to the next hole. When you finish that, return to 5 millimeters again, or plane. When you finish that, you go to the next one. That one reduces the cycle time for multiple holes. While when you use G98, the tool returns to initial plane before it started drilling. For example, 10 mm above the workpiece. This will help you to inspect the hole or remove particles before moving to the next hole. Now, what about PP, which is here? PP is dwell time in milliseconds at the bottom of the hole. So when it finishes drilling, you specify amount of time that it will dwell, maybe to do clearance at the bottom of the hole before it retracts and go to the next hole. F is the feed rate mode. It can be feed rate in millimeters per minute. Now when you come to the second line, there is XXN, YYN, then the third line XXM, YYM. XN is the position of the end hole, can be the second hole, and G90 and G91 modes apply. Whether you use absolute programming or incremental programming, their modes apply. Now when you come to YM, YM is the position of the end hole along Y-axis. G90 and G91 modes apply. Now let us look at an example. And in this case, we are using G90. That is absolute programming. The first hole is located at 30 mm from the origin. My origin is bottom left, 0, 0. The first hole is 30 mm along x-axis. The second hole is 80 mm along x-axis. And the third hole is 80 mm along x-axis and 60 millimeters along y-axis. Now, how do we program to drill these holes using Gantt circle? We have two options. The first one is to start drilling and just drill once to the bottom of the hole and just move out and go to the next hole, drill deep into the bottom of the hole and go to the third hole. So this is a straight drilling circle, that's G81. The tool moves to position, drills to the bottom and then goes to Z plane. Now in any programming, the first line of code is save start line. After you write the program number at the top, then you have to begin with save start line. And what does this line do? You look the first part, G00. It tells the machine to move in rapid mode. And then you come to G99. You tell the machine to use absolute programming mode. And then G54. You are telling the machine to pick the first fixture. When you have several fixtures, you fix them on the table. And then you have to specify to the machine which fixture is it going to operate. And then there is G17. G17 will select X, Y plane. While machining, you have to work in two planes, either XY, XZ, or YZ. That's G17, G18, or G19. So in this case, we will be working on XY plane. Now the next code is G21. G21 will set units in millimeters. That's metric units. If you want to use inches, then you can use G20. Now then you come to G40. G40 represents tool diameter compensation cancel. Then G49 is tool length compensation cancel. You are cancelling tool length that you set on the previous circle. Then G80 cancels any existing Gantt circle. You don't want to mess the tool. Now this is what we call save start line. At the end of this line, we have to write semicolon to specify the end of this line. And then we go to the next line, tool number 1, M06. That's tool change. We go to the third line, set a spindle speed to 2000 revolutions per minute and to rotate in clockwise direction. The next line of code tells the machine to move rapidly to X30, Y30, Z 15 millimeters above the workpiece. Then of course you turn on the coolant M08. The next line of code, you activate tool offset 1 and move to Z initial point. This initial point is different from R5. This one can be, let's say, 10 mm. This is where the tool will be positioned before the first cutting operation begins. Now, Z is the depth of the hole, negative 20 millimeters. Retract plane 5 millimeters above the surface and feed rate of 10 millimeters per minute. After finishing the first hole, then we go to the next hole. This hole will be positioned at X80, Y30. All other parameters will apply. For example, the feed rate, the depth of the hole, Z negative 20, and retract plane 5 millimeters above the surface. The third hole will be at X80, Y60, and above parameters will also apply. When done, then you specify G80 to cancel G81 circle. Then you rapidly move to Z20. You return to home. Then you turn off coolant M09 and you finish your program M30. Program end and rewind. Now the second type of code is G83. G83 represents spec drilling. It is used to drill deep holes and allows for breaking and clearing of chips and for coolant to fully reach the bottom of the hole by fully retracting the tool from the hole between the pegs. The first line of code is safe start line, as we have seen above. Then tool change, set spindle speed 2000 revolutions per minute in clockwise direction M03. Now you move to position X and Y 15 millimeters above the workpiece surface. Then turn on coolant M08. Then activate tool offset and you begin your G83. Now you can identify the difference between this code and G81. In G83 there is Q negative 1.1 millimeters. This one means you drill circle and retract after 1.1 millimeters deep. So after 1.1 millimeters down, the tool will retract for coolant to penetrate and also for chips to come out. The next circle again 1.1 downwards and retracts. The third in that order until it reaches Z negative 20 millimeters. So when it's done with this hole at position X30, Y30, it will go to the second hole at X80, Y30 with the same above parameters apply, and finally the third hole at X80, Y60, and then G80 you cancel can circle, and then rapid move to Z20, turn off coolant, and of course program end and rewind. So there is a short glossary of what I used above. G00 is rapid mode, G90 is absolute position mode, while G91 is for incremental positioning. G54 is fixture offset, G17 is XY plane select, G21 represent millimeters mode. G20 can be used for inches, while G40 is cutter compensation cancel, G49 is tool length offset cancel, G80 cancels existing Gantt circle, while G99 is R point return. You can alternatively use G98, which is for initial point return. Now I use the software, CAM software, and this is what I got. So you can see program starts with percentage, and then program number 1, 2, 3, 4, followed by tool parameters. So tool diameter 12 millimeters, then Z depth of cut is 20 millimeters, and it is drill tool. Now second line of code is safe start line, G90, G94 which is feed rate per minute, and then G17 XY plane, G49, G40, G80 all are the same. Then G21 millimeters. Then it takes machine to origin. G28 takes machine origin. Now tool change M06, then spindle speed M03, speed of 2000 revolutions per minute, and then fixture offset G54. In our case, we had placed here G54, and then coolant M08. Now it will go to rapid mode to position X30, Y30, then activates tool offset at Z 10 millimeters, and then it moves down to Z axis 5 millimeters above the workpiece. G81 X30, Y30, Z negative 20 millimeters, retract plane 5 mm, feed rate of 10 revolutions per minute. And then you see in the next line it will go to X80, and the machine knows that it's still along Y30. The next line, because it's X80, it will just go directly upwards to Y60. And then G80 to cancel above can circle. You return to Z plane. M09 turn off coolant. Return to machine origin. Tool length compensation cancel. These ones are not necessary. You can delete them. All this, because you have finished machining, you have returned to Z10. Then you can just turn off coolant and program. Just as simple as that. So I hope you enjoyed watching my tutorial. See you in the next video, where I'll be showing the other cane circles. Before there is G71. Stay tuned for the next one. Don't forget to subscribe and turn on notification so that you will not miss my next video. Thank you.